In this video, we will show how to georeference an EPANET network using a background map. The idea is simple. We start with a network that already has its internal geometry, but is not yet aligned with a real location on the map. To achieve this alignment, we use control points. We select a few nodes from the network and tell the system their real-world coordinates, latitude and longitude. First, we load the network. Here we can see an example network being loaded. If we place this network on a background map, it will appear somewhere that is not exactly where it should be, geographically. So we go to Google Maps and note a reference point from that area. Obviously, the network will not be georeferenced since we are taking a random point, but it helps us place the map behind the network. We note the coordinates of that reference point. Then we go to Settings, MapTiler Map, and enter the values of the point we just copied. We use a zoom level of 17 and click Apply Map. The map area appears automatically, but the network is clearly not georeferenced yet. Notice the network looks smaller. It is not actually smaller, it is just not properly georeferenced. We increase the background opacity. You can see the streets and how the network is shifted from where it should be. To georeference it, we will take 2 or 3 control points. 3 points gives a more accurate result. Try to distribute them well across the network, not too close to each other. For each of these nodes, we look up their real coordinates in Google Maps. For example, let us assume we know where node 650 is located. We take its coordinates from the map. We open the georeferencing workspace. From here, we can add control points in 2 ways: selecting a node directly on the canvas or using a previously selected node. We assign each one its real geographic coordinate. In Settings, under MapTiler Map, we have 2 options: add control point or select one node to add. For example, suppose we know where node 276 is. We look up the latitude and longitude for node 276. These are the values we enter here. We repeat this for all 3 nodes. Here we have a prepared example with 3 nodes already set with their latitude and longitude, previously found on Google Maps. We load those points. Now we have 3 control points, nodes 577, 913, and 825. Each defined with the latitude and longitude we looked up on the map, since we knew where those nodes are located. When we are satisfied, we use Accept Fit. This step applies the visual alignment of the network over the map, but keeps the current view so we can easily compare. This way, we can immediately verify if the network landed where it should. If we want to persist that alignment into the network geometry, we use Bake Transform. This writes the new georeferenced coordinates into the nodes and vertices. And if we also want to recalculate the geometric pipe lengths based on the new geometry, we can do that with recompute lengths. This is a separate action because often the user prefers to keep the original lengths from their GIS, spreadsheet, or original model. Thanks for watching. If you found this useful, subscribe for more tutorials on hydraulic engineering tools. See you soon.